Now let's look at another example of how the Jacobian can be used to evaluate an integral. It involves the substitution method, like in Cal 1, but now we're doing it for double integrals. So in Cal 1, we had let u equal something. Now we're going to have u and v equal something. Now notice, in this particular problem, we're asked to evaluate this integral over this region here in the xy plane. And of course, what we want to do is we want to convert this. We want to use this substitution to get a double integral that's no longer in terms of x and y, but in terms of u and v. So I want to find out, well, what's going to be my corresponding region over which I integrate in the uv? So I need to get a formula for, well, u equals this and v equals this. Now we already have u equals y. I need to figure out what v equals. Well, I could do this. I could say, well, x minus y, notice that's u plus v minus u, that equals v. So v is equal to x minus y. So we've got a couple of things here. We've got, if we have an xy, I can figure out what the u is. The u is just equal to y. And the v is equal to x minus y. So let's see if we can take these points, 0, 0, 3, 3, 7, 3, and 4, 0. Let's see if we can figure out what those are in terms of u and v. Well, this one is just 0, 0. Now let's try this one. This one's 3. If for the point 3, 3, we've got u equals y, so that's u is 3. Now for v is x minus y, so that would be 0. So let's dig what we have here. We have 0, 0, and we have 3, 0. 1, 2, 3, 0. Okay. Now let's try 7, 3. Well, the y is 3. Actually, okay, I've got it. 3. Now, 7 minus 3 is 4. Okay, so we've got 7 minus 3 is 4. So we've got this 3, 1, 2, 3, and 1, 2, 3, 4. Got a point up here. Now let's try 4. 4, 0. So the u is 0. And the v is 4. So it looks like we've got a nice rectangular region here. Okay, no worries. It's a nice region to integrate over. Okay. And of course, this up here is 3, 4. This is 4, 0, or 3, 0, I should say. This is 0, 4. And of course, down here is 0, 0. Now, we're just about ready to set up our integral because we've got the bounds of integration. I need to calculate the Jacobian. Now, remember the Jacobian is we're going to calculate it this way. It's going to be the partial x with respect to u, partial x with respect to v, then partial y with respect to u, partial y with respect to v. Okay, so that's how we're going to get the Jacobian. It's going to be the absolute value of that. So let's see what we've got here. This is going to be, let's see here, partial x with respect to u. Well, x is equal to u plus v, so this is just 1. Partial x with respect to v, well, that's 1 as well. Okay, so see, I'm getting it up here. Now, partial y with respect to u, that's 1. Partial y with respect to v, that's 0. So let's see what this Jacobian is. It's 0 minus 1. So 1 is what we're going to use. We're going to use the absolute value of this thing. Now I set up my double integral. Okay, so notice I've got y times u minus v. Well, y is u. Okay, see? So y is u, and x minus y, let's see here, x minus y is v. There. Times 1, and then we can just do du dv. Or dv du, it really doesn't matter. But notice I just made my substitutions in there. And you can see clearly that y and u, I can just substitute y for u. And then x minus y, that's this right here, I'll just put that as v. Now, as far as my integration goes, u goes from 0 to 3, and v goes from 0 to 4. So if we want to integrate this, here's what we've got. We've got 0 to 4. Now, I'm integrating with respect to u first, so this is 1/2 u squared v from 0 to 3 dv. Okay? Just integrating with respect to u first, and this is going to be 0 to 4. Let me bring this 1/2 out front. And this is going to be 9v. Okay, now I integrate again. This is going to be 9/2 v squared from 0 to 4. And let's see what that's going to give us. That's going to give us, well, this is going to be 9/4 times 16. Okay. Now that, 16 divided by 4 is 4, so this is going to be 36. And there you have it. So there you notice, from start to finish, this is how we would make a substitution with the double integrals. We use this Jocobian, okay? So remember, this Jocobian is key.